Excellent. Thank you. Nice Zoom lady. So hi, everyone, and welcome to our panel presentation on current uses of AI in archival description, hosted by the SAA description section. My name is Beth Cope, and I'm the current chair of the description section, and I was joined in organizing this panel by my fantastic colleagues and fellow steering committee members, Corey Charrington and Scott Kiricki. I want to start the meeting with a brief statement on the fact that this panel is intended to provide food for thought about the ways AI can be used in archival descriptive work, but with full awareness of the fact that there are larger questions about the use of AI, its boundaries, the energy it takes, and the ethics around its use. I'm sure these quandaries may come up through the presentations today, and we welcome conversation around the topic. I can also say that I think these conversations will be held in a variety of ways come August at SAA, virtually and in person. And given the enormous interest in this panel, I hope this is just the first of many such discussions, whether at SAA this summer or elsewhere over time. And with that said, I want to go ahead and move us into the rest of our panel for the day. I don't want to take up too much of our time, as we do have a lot to cover. The rest of the hour will go like this. We'll have 4 presentations, and you can see the agenda on this slide. They'll bring a variety of approaches to archival descriptive practice and artificial intelligence, and then all 4 presenters will go, and then we'll have a Q&A at the end of the full panel moderated by Corey Charrington, and then I will wrap us up right before the end of the hour. It's going to be a busy hour. So without further ado, I'm going to turn it over to Mara Gregory to lead off our panels, and I will stop sharing my screen.
Great, thank you. I will share my screen. And slideshow. Okay, hi everyone. I am Mara Gregory. I am the Dartmouth Digital History Initiative Fellow based in the History Department at Dartmouth College. And I am going to be talking to you today about enhancing access to oral history collections with natural language processing. So this presentation is actually an update on a presentation that was given by some of my colleagues at SAA in 2024. This project that I'm going to be talking about is a collaboration between Dartmouth College and the University of Kentucky to update the oral history metadata synchronizer, or OHMS, with new data annotation and visualization methods. And the goal is to offer new ways for researchers to access and discover information from within digital oral history archives. And I do want to acknowledge that this project was funded by a grant from the National Endowment for the Humanities. And like so many other projects, we learned last week that this grant has been terminated. So we are very disappointed, but we are also hopeful that we're going to find a way to continue the project. We're really dedicated to it, but there is a new level of uncertainty around it. So I just want to acknowledge that. So to talk a little bit about the partners in the project, the Oral History Metadata Synchronizer is a web-based system for managing digital oral history collections established by the University of Kentucky in 2008. It has 2 components. It has the OHMS application, which is the backend. That's where archivists or anyone who's managing an oral history collection can create metadata. That application is part of the Aviary platform, and it is available through a free subscription. And then the other component is the OHMS viewer. That's the user interface where researchers can explore oral histories. So just to show you a little bit about of what this looks like, this is part of the OHMS application. So you can use the OHMS app to create metadata at the interview level as well as at the interview segment level for an index of an interview. And then the OHMS viewer, this is the user interface again. This is where a user can explore a transcript and index of an oral history as well as the audio or the video. This is downloadable for free, and it can be integrated with basically any content management system. The other partner in this project, the Dartmouth Digital History Initiative, this is a digital humanities project launched at Dartmouth in 2019, dedicated to devising new tools and methods for exploring data within oral history archives. And we have a 3-part workflow that I'll talk about in more detail. So first we start by encoding oral history transcripts using named entity recognition. Then we link out to external knowledge bases using named entity linking. And finally, we create data visualizations. So what is named entity recognition? This is a form of natural language processing that seeks to automatically extract information from a text. It seeks to identify named entities and put them into categories. So for the DDHI and now OHMS, the entities that we look for in oral history transcripts are names of people, places, organizations, events, and dates. I won't go into much detail about how this works, but basically NER models are trained on data sets, and then they can predict where entities occur throughout a transcript or throughout a text based on context. We use Spacey. This is a free and open source library with multiple different models and pipelines for natural language processing. We use their small English model, and it comes pre-trained and with certain built-in entity types. So it is already trained on recognizing those 5 entity types that I mentioned. This is a snippet of an oral history transcript. It is encoded in XML, and you can see entities have been encoded throughout it. So we have tags that designate where the entities occur and the type of entity you have. And then the next step in the process is the named entity linking. So we link all those encoded entities throughout the transcript to an external knowledge base. In our case, we use Wikidata. So we're able to associate each entity with a unique identifier, in this case, the Wikidata QID, as well as other contextual information, for example, geocoordinates for a place. And this allows us to create data visualizations. So here you have an example of a map that has places that are mentioned in an interview marked, and these places are associated with the place of the transcript where it is mentioned. So our goal with this project is to bring some of these natural language processing capabilities into OHMS. And we are doing this first by creating a new OHMS application that incorporates natural language processing in order to facilitate metadata creation. So when a OHMS user requests natural language processing for a transcript, the NER and the NEL automatically go through the transcript and suggest where entities occur and suggest links to Wikidata for each entity. There's a user interface that allows for editing of those entities and those links. And then we're also working on, especially towards the future, different options for aggregating and exporting that entity data. So I am going to stop the slideshow and just show you a little bit of what this looks like in practice. So what you are seeing here is the OHMS transcript editor. And this transcript has had the named entity recognition run on it. And so you can see different entities have been tagged throughout the transcript. They are color-coded based on the entity type. They are linked to Wikidata. So here we have, for example, the TVA, the Tennessee Valley Authority, linked to the entry in Wikidata. And we also have a good deal of metadata that is pulled in automatically from Wikidata about this particular entity. So we have really granular description here. We have word level description happening, and all of these metadata fields are editable as well. So we have this really granular level of description. We also have potential to use this for other levels of description. So we have here a summary of all of the entities that have been tagged throughout the transcript. So an archivist could potentially use this to do some interview level description, creating subject headings or keywords, or looking for something that has been missed in pre-existing interview description. And then we also are working on various different options for aggregating the data. So potentially pulling out some of this data from multiple different interviews and using that for collection level description. So I'll go back to the slides. And the other thing that we're working on, hopefully in the future, is creating a new OHMS viewer that includes data visualization capabilities, so that provides new ways for a researcher to access and discover information from within oral history archives. And I think it's interesting to think about data visualization as a form of description as well, both to provide access points and different ways of discovering information within a particular interview, as well as across interviews and at the collection level. So lots of considerations go into this, especially with oral history collections. Some of the benefits, of course, it is automated, so it is very fast. The natural language processing tools are capable of working on large data sets, so long interviews, large oral history collections. These can be very difficult to describe as well as to access for researchers. These tools are available in multiple languages if your collection contains interviews in different languages. There's a range of costs and capabilities depending on the needs and budget of a project. There are different languages available. There are models that are trainable using machine learning. There's lots of different options. Of course, there's lots of challenges. There's lots of errors. So the initial pass that is done by the NLP is not fully accurate by any means. There are frequent errors where it will miss entities, it might miscategorize entities, it might tag something that should not be an entity. So that user interface that I showed you, the editor, everything can be edited by a human. That's a very important part of the process. Like any AI tool, there is going to be bias baked into the way that it is trained, and there are limitations. Various different models have different entities that they can categorize, different languages that they work in. And then, of course, privacy is a big concern. Privacy with oral history collections, if we're tagging certain entities, we are actually making them more discoverable. So if we're tagging people's names and associating those with metadata such as dates of birth, you could potentially be putting a lot of personally identifiable information into the metadata. And oral histories are often with people who are not famous people, talking about their everyday lives and people that they know. All of this underscores that human review is essential. These tools can provide some efficiencies with working with these collections, but they in no way take away the human element, the importance of human deliberation and care when managing these collections. So thank you. I will stop there and I will pass it on to, I think, Ken and Hope.
Hi there. Let me see if I can share my screen here. All right. Thank you for having me. Good afternoon. My name is Ken Axford. I am a project archivist at the University at Buffalo in the University Archives. Oops, excuse me. And today I'll be discussing a pilot project we've conducted in the University Archives, where we explored how consumer-level AI tools can be used to generate descriptive metadata for digital archival collections. This project aligns with broader trends in digital scholarship, automation, and AI-driven workflows in archives and research institutions. Some background. The focus of our pilot project is on the WBFO Radio Archive, which is a collection of over 2,000 hours of historical audio, recordings from our former campus radio station, WBFO, produced between 1959 and the early 1990s. This audio has been digitized from its original reel-to-reel tape format and then transcribed to text documents using Adobe Premiere Pro. Our goal with this project is to use generative AI to create both short and long-form metadata descriptions from our text transcripts. A few notes on the importance of metadata in digital archives. Good quality metadata is critical to facilitate access, discoverability, and long-term preservation of digital collections. Traditionally, metadata creation tends to be a very resource-intensive and time-consuming process, which can make it a bottleneck for large-scale digitization projects like this one. One of the biggest roadblocks with this project was the scale of the collection and our available staffing. We started exploring AI options that were available to us without adding additional costs to the project that could help to move the project forward. The reels themselves also lacked descriptive information, as you can see in this image. Many were simply labeled unknown. And without the assistance of these AI tools, the project likely would not have been possible. Consumer-level AI tools like ChatGPT Pro and Microsoft Copilot offer promising opportunities to automate the metadata creation process. However, the effectiveness and appropriateness for use in archival description can vary based on model design, data privacy policies, prompt structure, as well as the complexity of an institution's metadata needs. As institutions explore the use of AI models for metadata creation, it might be helpful to think about these tools using the metaphor of a vehicle or a mode of transportation. They can all get you from point A to point B, but they will vary in terms of price points, speed, and user friendliness. Our goal with this particular project was to identify a solution that was more similar to a bicycle than a sports car. It could be affordable, accessible, and practical for smaller institutions with limited resources. Next, I'll dive into our process for creating descriptive metadata with these generative AI tools. As I mentioned earlier, we began by creating text transcripts of our audio recordings using the speech-to-text tool in Adobe Premiere Pro. These transcripts were then manually reviewed to assess their accuracy, contextual relevance, and efficiency. Transcripts were also lightly reformatted to make them more readable for users. We want these to be, valuable for accessibility as well. This process and really every step in our pilot project has required refining to balance the benefits of automation with the need for human oversight. With our transcripts in hand, we began comparing two widely available AI models. These are OpenAI's ChatGPT Pro and Microsoft Copilot. And this comparison entailed performing A/B tests on select transcripts to evaluate the suitability of each AI model. We were concerned with the quality and reliability of the results, as well as privacy and security considerations. Early results with a simple prompt showed significant variance in the AI-generated summaries, leading us to refine our prompts with more clear, specific instructions. As you can see, our initial prompt was very basic, just asking the model to create a 2 to 3 sentence summary. Later, we added we asked the model to include specific details, facts, figures, and names, to only include information that is directly stated in the transcript, and to maintain an objective and neutral tone. And we've continued to kind of iterate on this prompt as we've gone, and we will likely continue to do so. So you can see with a simple prompt, with our initial prompt, ChatGPT generally produced higher quality results with a greater degree of specificity. However, in this particular case, you can see that Copilot was actually able to identify the speaker, whereas ChatGPT-4 did not. We continued testing with our more complex prompt. And with this more complex prompt, the quality of Copilot's responses was significantly improved and generally roughly equal to that of ChatGPT. Here you can see that there are far more specific details, names and organizations mentioned in each of the outputs, as well as a greater degree of, there's more historical context, more detail overall. Privacy and copyright concerns were ultimately what influenced our decision to use Copilot within our university's Microsoft 365 environment. Unlike ChatGPT, Microsoft 365 Copilot ensures that institutional data is not used to train its AI models. Keep in mind, however, that this is not the case with the free personal version of Microsoft Copilot. We were fortunate enough to already have a license to the enterprise version. AI adoption in archives must align with data governance policies and compliance regulations, such as the GDPR and your own institutional policy frameworks. We have had to navigate some common shortcomings of generative AI tools as we've developed our process for this project, most notably the phenomenon of AI hallucinations, where the model would generate incorrect information or fabricate details from scratch. This proved to be particularly problematic when we explored the possibility of using Microsoft Copilot to identify relevant Library of Congress subject headings for our audio transcripts. Copilot inconsistently assigned these subject headings and sometimes invented non-existent terms. When presented with the same prompt multiple times in succession, Copilot would return significantly different results each time, and it also provided misleading and incorrect citations for its results. So here you can see that we asked Copilot to provide URL citations for the results that it pulls from its prompt. And at first glance, they all look fairly authentic and legitimate. But then if we actually follow those URLs to their destinations, we find that they link to different LC subject headings that are not relevant to the transcripts and are not what they claim to be. We tried a few different versions of our prompt to generate LC subject headings without yielding reliable results. So we ultimately decided not to use Microsoft Copilot for this purpose, opting instead to manually select our subject headings to include in our metadata. These findings reinforce the need for human validation in AI-driven metadata workflows. So, in conclusion, we found that this project demonstrates the potential for AI to streamline archival workflows, while also highlighting critical challenges such as data privacy concerns and the risk of AI hallucinations. As research institutions explore AI adoption, collaboration between archivists, technologists, and policymakers is key to ensure responsible implementation. These models can be powerful tools, but they are not solutions for metadata creation in and of themselves. Time, staffing, and the need for human oversight are all necessary considerations to ensure success and maintain adherence to ethical standards in digital archives. Thank you so much for having me, and I'm happy to answer any questions in our later Q&A section of this meeting. I will hand off the screen share.
Nicole, you're muted.
So sorry about that. Let's go back here. Welcome everyone. Now that I'm unmuted, I'm Nicole Critchley and my co-presenter is Sridevi Wagle. We're going to present on a project that we're currently working on that is to develop an AI-powered search for historical scientific collection. So today we're going to cover who we are, what the collection is, and how the project is going so far. So we're the Northwest National Laboratory, or PNNL. We are one of 17 national laboratories, a part of the Department of Energy. It was established in 1965 when the Atomic Energy Commission officially transferred operations of the Hanford laboratories to the Mattel Memorial Institute, who still runs this today. Our areas of research are pretty wide, ranging from national security, power grid resiliency, cancer research, and to atmospheric and weather research. We manage the public reading room for the DOE that is located on Washington State University's Tri-City campus. The reading room provides public access to various DOE resources and consists of primarily technical reports related to the current and historical operations at the Hanford site, but also maintains administration materials, fact sheets, handouts, and scanned historical images of Hanford, including construction photos. The Declassified Document Retrieval System, or DDRS, was created as a result of the Hanford Declassification Project. This project started in 1994 and ended in 2003, but the website was taken down in 2013. DOE wanted this put back up, but P&L inherited these digital files and metadata via a hard drive and moved to integrate that into the public reading room catalog around 2013-2014. So as it stands, there are limitations with the existing catalog system. The old user interface isn't very user-friendly, and it's not able to filter or limit by product or format type. So you have to know how the negatives and photographs or document numbers are formatted and enabled in order to search for them. There isn't full text search, so text graphs and charts within these reports that hold a lot of scientific data are not accessible from the current user interface. For example, the use of certain chemical processes might not be named in the title or keyword, but that's what the document is about. There's a lack of rich metadata, especially for photographs. And some of the titles and keywords are not always helpful since they use jargon that only makes sense if you're familiar with the Hanford site. There's also the low quality of the scanned documents. These are not OCR'd, and they're currently very difficult to OCR. And this isn't an issue with the digitization itself, but from the original scan material, much of which was microfiche or microfilm. There's a lot of very faded serif type font, handwriting, stamps, and crossing off of text. So the idea for this project came out of a hackathon project, which Sridevi, myself, and other librarians participated on, that put together an AI chatbot that was trained on many library resource pages that we had created. After that project didn't get funding to move forward, the idea for this project formed as there was an interest and energy around AI-powered searching from leadership. We have a collection that is hard to find, like the reading room content, and building an AI search tool or chatbot would help surface it. A specific collection like DDRS is a good case study to develop a proof of concept, as it's publicly available content and has been so for years. So this is our current project team, and now I'm going to hand it off to Sridevi to talk about the data.
Yes, thank you, Nicole. Hi, everyone. I'm Sridevi. I'm a machine learning engineer at PNNL, and I mainly work on data science applications. So as Nicole already mentioned about the data, I'll be giving you a more statistical view of the data. So we have around 1.5 terabytes of data, most of which is in TIFF format, and very few in PDFs and JPEG format. So you can see TIFF format is tagged image format. It's basically a PDF file, but stored in a TIFF file. And we have an example of PDF and JPEG as well. Next slide. We have three major issues with our data, the first being duplicate records. So we have these images and PDFs that are named differently and available in different locations, but they are the same PDFs and same images. And second being the poor scanned quality, as Nicole already shown one of the PDF examples. They date way old back down to 1950s and 60s, and they have these errors, like hard to read with the scanned copies, even with OCR. And the third issue is page level scanning. So as I already mentioned, that most of our data is in TIFF format. So we have around 4 million files in TIFF format. And for example, if we have a PDF with 10 pages, so instead of saving it as one PDF, we have 10 separate TIFF files. So we're working on consolidating all of these into PDF formats and addressing these data issues. Next slide. So in order to overcome our limitations from the existing search tool, we have our AI-powered search tool for which we have created a backend. And I'm just going to explain the backend, how we have architectured it. So as our raw data set, we have PDF documents and images, and we send it through a data extraction pipeline powered with large language models that is capable of extracting text, identifying images, OCRs, and tables. And once we have this extracted text from images and PDFs, we send it to a data pre-processing pipeline where we perform data standardization. So basically, we organize this extracted data into page-wise content, so each page-level text. And once we have this page-level text, we pass it to our next pipeline, which is knowledge extraction. So in this, we basically enrich our data by adding metadata to it. So for PDFs, we add metadata fields like title, authors, published date, etc. And for images, we add metadata like figure caption, any OCR that is extracted, or a text embedded, extracted from the images that are embedded within those images, etc. And once we have these curated and organized data set from both text and images, we ingest this data to a database, so which is open search database. In this case, we create an index and ingest the database. And this serves as a backend for our multimodal AI-powered search app. So next slide. So this is our multimodal AI search app, which is capable of retrieving both text and images. So for example, if you just type in Hanford site construction, we get all the documents, PDFs, and images related to Hanford site construction down to the page. So here, for example, you can see page 11 has that information related to Hanford site construction. And yeah, so, and these are PDFs named with just the documents. We are trying to improve that as well in our next iteration. So let's say another example, chemical reactions using tank waste treatment. We do not have any images, but we do have PDFs. So it doesn't give you, if the search fails to give the exact or the PDFs are not available, it tries to give you at least the related search results. For example, here, process waste disposal, I can see one of the headers. So even if there is no exact search for chemical waste treatment, for waste disposal, we do get related search like process waste disposal, and so we can improve our document discoverability, and the user is given more information and details down to the page wise accuracy. Yeah, I think, yeah, these are the two examples that we had with our first set of iteration. I think we just have 50 documents in this search app. So as part of our next steps, what we have planned is to use vision models to for image recognition, for example, just to get more data out of these images, and also adding more metadata to search results. As you've seen in the demo, the search app, we do not have a lot of metadata involved. So we are planning to add that as well, and mapping the document names, making the document names more readable, and also developing a chat bot so that you can chat with the documents, and also using the AI to correct our extracted text from the OCR and old scanned documents. So these are still in our experimental stages, but yeah, I think that's pretty much it for our presentation. So please feel free to reach out to us if you have any questions. So thank you so much. I'll hand it over to the next person.
Hello, I am Liz Bloodworth, and I am the University Archivist and Special Collections Librarian at Illinois Wesleyan University. And today I'm going to be talking to you about accessible AI in the archives using ChatGPT for archival description. For this project, it was a pilot project, and we tested consumer-level AI tools for improvement of existing descriptive metadata of an already published digital collection that I will talk about a little bit in the next slide. We wanted to leverage these tools for also the creation of summaries of individual letters. And with that in mind, we hoped to increase the discoverability of letters in that. Can you not see the slideshow?
We can see the slides, but I think you need to just hit the from beginning button for me. Thank you.
Okay. Yeah, I can do that. It's showing on my end. This is weird. Hold on. Can you see it now? Like am I in the slides?
We see like the regular like editing mode. We're not seeing a slideshow.
Okay, okay. Hold on. Let me do screen. Okay, let me share that screen. Is that better?
Yes,
Yes.
that is
Okay.
slides. Awesome.
Okay.
Sorry about that.
So,
Zoom loves to throw things at us.
Yes, and I have 3 monitors going, so it's all right. So this collection is the Fred Bryan collection of World War II correspondence. It is an already existing digital collection that is already described to the item level, but it has very minimal description. So Fred Bryan was an alum of Illinois Wesleyan and later a professor. While he was a student, he enlisted in the Army Air Corps and served as a pilot and navigator, spending most of his time in Africa, Italy, or South America. And the collection contains 324 letters in total that are dated from 1943 to 1945. They are all handwritten in cursive, and the minimal description makes it hard for researchers to find specific letters that might fulfill their needs. So that was the impetus for this pilot project. Sorry, now the slides are being weird again. I'm going to stop share and start share. We're just, can you see them if I go to the next one? Can you see that one?
We're back to seeing like the main slides, like editing page. Sorry.
I'm so sorry.
Not at all. These things happen.
Okay. Let me end the slideshow. Let me go back.
If you want to use the editing page and just scroll through them, that's okay. They'll be a little smaller, but it will totally work.
Can you see the editing page right now?
No, now we are seeing slides.
It's just because it's sorry. Okay. Let me just stop the share and start it. Let's see. I'm gonna try to just do it here. Okay. Are you seeing the slides or no?
We're in the editing page, but yes, we can see the slides. So I would just scroll down through this.
That's what I'm gonna do. Okay. Okay, so the current item level metadata is here. So on the slide, you can see what it looks like in content DM. So this is before we ran it through AI. And it does have some basic information such as the date and the author, but the thing that I was really hoping to improve, the field I was hoping to improve the most is the description, which here is showing as only letter 1 and travel, so that doesn't tell you too much about the letter itself. So with that in mind, I wanted to test the use of ChatGPT to improve the existing metadata. I did that in a kind of two-phase process here where I prompted ChatGPT for Dublin Core metadata for descriptive summaries and keywords. And then the second part was asking ChatGPT for Library of Congress subject headings, all in an attempt to improve that item level metadata. To do this, I needed to provide ChatGPT with transcriptions of the individual letters, which were created through Transcribus, which is an AI software that we used for handwritten text recognition. And I also then offered ChatGPT any information that was missing from the transcript. What's interesting, when you ask ChatGPT, you can say, hey, you could ask ChatGPT about its level of training in Dublin Core and Library of Congress, and it does recognize that I have that ChatGPT, if ChatGPT is speaking, has some knowledge of what Dublin Core metadata is, what Library of Congress subject headings are, but it does not have training specifically to offer that metadata, and as a result, it does recommend that archivists or librarians offer human oversight on that. So that's an interesting thing. Because of my tech issues here, I'm just going to skip over the demo. All that I was going to show you was what it looks like when I place the transcript into ChatGPT and ask for those keywords. When you get the material back, this was an example of asking for Library of Congress subject headings. The ChatGPT was able to offer us Dublin Core metadata that expanded on what was already available, as well as longer descriptions other than that letter 1 or that travel notation that was there before. So that is really where its strength lies. This screenshot is for ChatGPT's return for Library of Congress subject headings. And like a previous presenter noted, the Library of Congress subject headings did include some hallucinations there. They look okay on first glance, but then when you dig in a little deeper, they are not, for example, air raid precautions is not an actual subject heading in Library of Congress. So that suggests the need for more human oversight when asking Library of Congress, asking for Library of Congress subject headings. Overall, the results I found were speed with the automation. For Dublin Core metadata and the summary descriptions, as well as the Library of Congress subject headings, the returns were about 15 seconds per letter. So that's very quick, and quicker than I think I could have either myself or another staff member in the department return Dublin Core metadata. So that's great. The summaries were longer and opened up additional avenues for accessibility and discoverability of these letters that we would not have had before. And that's all can lead to improved item level metadata. Weaknesses, though, as I said, were those hallucinations with Library of Congress subject headings, need for human oversight to identify errors and to monitor for potential biases, and that adds to that time factor. So just moving on to future opportunities. This pilot project demonstrates that it is possible to use AI tools to help improve existing item level description, but there's other opportunities such as testing ChatGPT for the creation of local controlled vocabulary, comparing usage statistics after implementing this new improved metadata, and auditing these descriptions for any potential biases. So that is all. Thank you.
Thank you, everybody. That was wonderful. So my co-facilitator, Corey, is going to facilitate the rest of our time, which is really going to be discussion, and then I'll wrap us up at the end. So if you have any questions, please go ahead and put those into the chat, or feel free to raise your hand.
I have one comment on the ChatGPT hallucination thing that both Liz and Ken and I sort of experienced in different ways. I was on a different AI presentation panel, and what I found to be really useful is in the prompt to actually give ChatGPT or Copilot or whatever platform you're using the chance to fail. So you actually engineer the prompt to say, if you can't answer this, please say you can't answer it. And that helps a lot with hallucinations because they want so badly to please the end users that they create information. So just allowing the actual AI tool to come back with a negative response seems to help in the prompt for those types of issues.
Okay, and it looks like we have a question in the chat. Presenter, what error rates were you finding if you tracked them?
I can try to speak to this a little bit. We didn't track, you know, detailed error rate statistics. I would say it really depends on the application, though. Again, for identifying LC subject headings, the error rates were quite high. For generating brief summaries based on longer pieces of text, which really seems to be a strength of these models. They were far more reliable, and I would say especially when presented with a more complex prompt that gives it specific instructions. One suggestion I've heard is to treat these models sort of like an intern who's like just learning how to do their job, to give them as much information as you possibly can. And in those instances, the error rates were far lower, specifically for summarizing text.
Okay, if we don't have any other responses to that question, we actually have another question for Ken. You find it again, the chat is moving. Okay. Okay, Ken. I wonder if they actually timed the process of going through these processes with AI versus wholly with a human. So I think it's about timing differences.
Sure. We have not, like timed each each addition to our metadata for each transcript. But I will say that I'm certain that it is much faster using the AI models to generate the summaries, in that most of our transcripts were upwards of 10 to 15 pages long. So it would either be a matter of having a human read the complete transcript or listen to an audio file that might be 30 to 45 minutes long. So I would say, on average, the process of inputting the prompt and the transcript to Copilot and then reviewing it for accuracy, might take 5 to 10 minutes per transcript, as opposed to maybe 30 minutes per transcript.
Okay, and we have a question about Transcribus. How was the experience of using Transcribus for transcribing handwritten letters? And can you give pros and cons, please?
Problem. I find it, so it's interesting. I think I had to test several different models because there are different models for English cursive handwriting. And some performed better than others. All of them are going to require, until you essentially you can train the software, the AI tool, on that individual person's handwriting, but that would take lots more data than what I did for this pilot project. So you do have to go back and edit, but there is a space to do that within the software itself. It's nice. You see the handwritten letter on one side, the transcript on the other, and you can go through and compare and edit, and then save it, and then use those corrections over time. I was floored the first time I put something in that program, how well it did. And I think for me personally, that would save time. I do have a student who I was asking to use it for a different collection, and that student prefers to transcribe themselves without the use of the AI tool. So I think it comes down to comfort level and your own speed. But yes, I thought it was fabulous. I recommend it.
Okay, and we actually have another question for Liz or anybody else in Friends. My concern with summaries of text is that you need somebody to read and analyze the individual letters. Sorry, chat is moving once again. Okay, was this done and analyze the individual letters to know if the summaries are accurate? Was this done, or do you present them with the caveat that this text was generated by AI and may not be entirely accurate?
Implemented the new descriptions into our current collection yet, but that would definitely be something that I would feel for the purposes of transparency, that somewhere either on the collection homepage that I do denote that AI was used to help generate these descriptions. Once I go through and add these, I mean, I did do some testing. It was fairly accurate, but I'm not going to say it's going to always be accurate. So I think being transparent about the use of the tool is the best way.
Cool, thank you. And question from Matt. For the AV Archivist, did you share any contextual information about the recordings with the AI when you prompted for description? For example, this is a radio broadcast from 1970. Speaker 1 is XYZ.
I mentioned in the chat, so we didn't share any additional contextual information about the broadcasts, but because they're radio broadcasts, they do tend to give introduction text at the beginning of the transcription, so the speakers usually introduce themselves. So that makes that process a little bit easier. We just had our generic prompt that we add into the chat bot, and then we upload a Word document that has the audio transcriptions. We're also working with really good quality broadcasts as opposed to a lower level audio format. So I think our transcripts were a better quality because of that. So everything just sort of filters down as a better quality from that initial recording.
Okay, and we also have a question about disclosing use of AI. In your processing / general notes, are you disclosing use of AI? If so, what kind of prose are you using / could you provide an example of what you might be saying? Yeah, and this could be for all the presenters.
We don't have this collection publicly accessible yet, as we're still working through the processing, but we do plan on having an AI statement at a collection level, not with each individual description, just because I think that's going to become really clunky. But we're going to have, I think it's important to be transparent on the process on how the descriptions were created, especially if you can't individually review every single one. That's definitely an important part of this.
Yeah, I'll comment that this search is not public yet. It's a long way to go before it's public, but we would probably have some sort of statement saying that it is AI powered, but it's a search system. So I'm not sure we wouldn't be able to put it on every single result. So same, very similar to Hope.
Okay, if we don't have any more responses to that one, okay, for any of the presenters or any participants, has anyone used AI tools to generate alt text for images? If so, what has your experience been like?
I have some experience working with extracting text from images. So mainly those are like text embedded within images, not so much of an AI, but sort of a data extraction tool, so which does pretty good job in extracting the text from images. So there is also a vision model that I use for one of the other projects that I've been working on, not very relevant to this presentation though. So that also seems to be doing a good job if you train it very well with you, if you have some good quality data set and feed it to the model, vision language model, and then it gives you really good with very less error rate.
Okay, and we have a question for Mara. Since you use Wikidata, did you have... Oh, this thing is updating constantly. Did you have to manually add local entities to Wikidata so you could use them in the tag metadata?
Yes, we did. So we have the Wikidata link as optional within this tool. So we anticipate that each institution or project that is using it would generate their own guidelines for when it's worth it to create a new Wikidata entry. For example, a person who appears frequently throughout the collection who doesn't already have a Wikidata entry, who is a somewhat notable person, it might be worth it to create a Wikidata entry for them. Whereas, lots of oral histories include mentions of, a local business or a individual person who probably is not going to be in Wikidata. And in those cases, partly for privacy, we don't require that you create a Wikidata entry.
All right, and we have time for just one more question. Let's go. Okay, I'm still mulling about privacy in ChatGPT versus Copilot. Does ChatGPT absorb your input into the system? Is that the issue?
There is in general I think the default privacy settings with the enterprise level of Microsoft Copilot are have better data privacy protections. That said, it depends on the version of ChatGPT you're using. By default, the free version, I believe, does or at least can use your input to train its models. Whereas if you pay for one of the higher level versions, it gives you more control over the use of your data.
Looking at this, Copilot generally has settings that protect your data as opposed to ChatGPT where you have to turn those on affirmatively. We ended up going with the enterprise version of 365 Copilot just because we had access to it, but even the lower level versions of Copilot have somewhat better protections. We ended up going with, again, the instance of Copilot within our institution because it keeps all of the data within the walls of that institution. There's just additional protections that we wanted. But a lower level of Copilot or even a paid version of ChatGPT are going to offer you some of those same services. You just need to dig into the settings quite a bit.
Awesome. So I think we are basically at time. Huge thanks to our panel of presenters for the great presentations, for much food for thought on this topic. I do think that this is certainly an area that we're going to hear a lot more about, but also that I think we should all keep in touch about, all 285 of us that were in the room at one point. Thank you all very much for joining us. And again, a huge thanks to our presenters. This was really wonderful and hopefully just the beginning of a much longer conversation. Have a wonderful rest of your days, and I hope it's as springy where you are as it is remarkably enough in Boston at the moment. Thank you and have a great rest of your day. Bye-bye.